Starting with two numbers a and b, not commensurable in square, whose sum of squares is medial and whose product is rational, we'll show that their sum is irrational. A squared plus b squared is medial, and since ab is rational, 2ab is rational. A squared plus b squared is incommensurable with 2ab, so that a squared plus b squared plus 2ab and 2ab are incommensurable. Or, a plus b squared and 2ab are incommensurable. 2ab is rational, so a plus b squared is irrational, so that a plus b is irrational. We'll call such a line side of rational plus a medial area. So a side of rational plus a medial area is the sum of two numbers, not commensurable in square, whose sum of squares is medial, and whose product is rational. An example of such a number is the square root of root 5 plus 2 plus the square root of root 5 minus 2. To show this, let a equal the square root of root 5 plus 2 and b equal the square root of root 5 minus 2. A squared equaling root 5 plus 2 and b squared equaling the square root of 5 minus 2. To show that they are incommensurable, assume otherwise, then EG equals root 5 plus 2 and EF equals root 5 minus 2, where g and f are whole numbers. E equals root 5 minus 2 divided by f, so that g over f is equal to root 5 minus 2 equaling root 5 plus 2. Therefore, g is equal to f times root 5 plus 2 over root 5 minus 2, which is equal to f times root 5 plus 2 squared over root 5 minus 2 times root 5 plus 2, which is equal to f times root 5 plus 2 squared, which is always irrational, so a squared and b squared are incommensurable. A squared plus b squared is equal to 2 root 5, which is a medial area because its square root, the square root of 2 and root 5, is the geometric mean of 2 and root 5. Two numbers, rational by Euclid's definition, and commensurable in square only, and thus the square root of 2 root 5 is medial, so that 2 root 5 is a medial area. Lastly, AB is equal to the square root of root 5 plus 2 times root 5 minus 2, which is equal to root 5 minus 4, which is equal to 1, which is rational, so overall, the square root of root 5 plus 2 and the square root of root 5 minus 2 are not commensurable in square. Their sum of squares is medial, and their product is rational. The sum, the square root of root 5 minus 2 plus the square root of root 5 plus 2, is thus a side of a rational plus a medial area. When looking for such numbers, the form the square root of root a minus b plus the square root of root a plus b may be helpful, where a minus b squared is a square. But be sure to check all the conditions.